If a ratio of two variables is constant, then the variables have this special relationship, which is called direct variation. The graph of direct variation equation is y equals kx. It's a line that passes through the origin, 0, 0, and has a slope there of k. A variation equation is a statement of how a change in one quantity relates to the change in another quantity. The direct variation relationship is that of as my x values increase, the corresponding y values will increase, or as the x values decrease, their corresponding y values must also decrease. These equations, direct variation, are a subset of linear equations. Not all linear equations are direct variation, but some direct variation are linear equations. So y equals x is the constant, and then of course, as stated, the graph will pass through the origin of 0, 0. So when we look at these first examples, they are asking us, here is, does this equation represent a direct variation? Well, one thing that we do know is, if so, find a constant variation. We need to find out, one thing we know, that it will pass through the origin, and if we need to, right now what we can do is we can put it into the y equals form and find out what we have. So in order in A here to get to y equals, we have to divide both sides by 7, and that's going to then simplify down to y equals 2 over 7x, and that does fit the format. I have a constant. I have a constant of variation. Y equals kx. K is going to be 2 over 7. It must go through the origin, and I can tell you now that this is plus 0. There is no y-intercept, so the y-intercept is going to be the origin, 0. So there you have it. You have all the criterias are met. And let's see here. So if we look at our next example, in order to get y by itself, I go ahead and subtract my x and move my x term over to the other side. And that gives me 3y is going to be equal to negative 4x plus 8. And if I divide by 3, I must divide by 3, everything by 3. And then I have y equals negative 4/3 x plus 8/3. This does not meet the direct variation requirement, because it does not pass through the origin 0, 0, because my y-intercept is 8/3. So that is not 0, so that does not meet my direct variation. So far we have yes, we have no, and we have to see what this next one is going to equal. And we have, go ahead and isolate your y term by moving x over to the other side. So I have 5y equals negative 4x, and divide both sides by 5. And it looks like I have y is going to be equal to negative 4/5 x. So again, I have that form we're looking for. I have a constant of variation, so I have y equals negative 4/5 x. Negative 4/5 is that constant of variation, and then it passes through the origin because I have no y-intercept other than 0. So as we keep going, and it says writing a direct variation equation, and it says example, suppose y varies directly with x. Well, that's y varies directly with x. You can also be written as y varies directly with x. So it says, and now it says y is 10 and x is negative 2. Well, if I take this and I go ahead and substitute in my values of y and x, I'm going to have y equals kx, do my substitution. I have y is equal to 10 times k, or equals k times x, and x is negative 2. Isolate my constant of variation, my k. I divide both sides by negative 2, and I know that my k is going to equal to negative 5. and k is my constant of variation. So I found my constant of variation, and it says, what direct variation equation relates x and y? Well, this is my equation, and now I have an unknown of k. Well, I've just found what k is equal to, so I just substitute it back in. Y is equal to negative 5x, and that is my equation which relates y varies directly with x, and the constant of variation is negative 5. And then the last part of this question is, what is the value of y when x is negative 15? Well, all you have to do there is substitute in negative 15 for x. So I have y equals negative 5 times the new value of x, which is negative 15. And when I simplify, y is going to be equal to a positive 75. So there you have it. We were discovering the value of k, the formula, the equation, and then finally a new value of y when x is negative 15. So that is writing the direct variation equation. And this next example, suppose y varies directly with x. Again, y varies directly with x, and y is equal to 40, and x is equal to 8. Go ahead and isolate your direct variation, or solve for your direct variation, and k is equal to 5, and the variation equation is going to be y equals 5x, and then it reads, what is the value of y when x is 12? So I have y is going to be equal to 5 times 12, 5 times 12, which is going to be 60. Y equals 60. There you have it. Walking through writing and using the direct variation equation. Okay, so graphing direct variation, it says the weight on the moon varies directly with the weight on the Earth. Okay, the weight on the moon varies directly with the weight on the Earth, right? Just doing a little bit of simple substitution there. So my moon is y, my Earth is x. And then it says a person weighs 100 pounds on Earth. A person who weighs 100 pounds on Earth weighs 16.6 pounds on the moon. What is the equation that relates weight on Earth x to weight on moon y? Okay, well, let's just do these substitutions here. Okay, the Earth pounds, the Earth weight is going to be 100. So we're going to have equals k times 100, and then the moon weight is going to be equal 16.6. And now let's just solve for that constant of variation. Divide both sides by 100, and my constant of variation is going to be equal to 0.166. And then my equation, which relates those two weights, will be 0.16, y equals 0.166 x. There's my equation. And it says, what is the graph of this equation? Well, let's go ahead and make our coordinate plane. Okay, so I'm going to have the varies directly, the moon weight to the Earth weight. As stated, the y values and the x values. Moon's going to be y, my Earth weight's going to be x. And I'm going to be using a very small decimal, actually, for my moon weight. So what I will do is I will just go by 0.2, my intervals of 0.2. And then I'm going to have my Earth pounds, and I'll just do intervals of 1, 2, 3, 4. Okay, so I've set up my grid, or the plane that I'm going to graph in. And when I do some substitutions, I find out that when values of x, and of course y equals 0.166x, y, when x is 1, y is 0.166. When x is 2, it is going to be 0.332. When x is 3, y is going to be 498, and so forth. And I'm going to stop with just these three points. So here we go, graphing 1 and 0.166 is going to be about right there. Graphing 2 and 0.332 is going to be about there. And then graphing 3 and almost 5 is going to put me about right there. So now we have a direct variation. And I can connect these because it is continuous. And there you have the graph. That's a graph of that equation. As we continue with direct variation, now looking at a table, and we created a table right here in order to graph, and that constant of variation, we might see that as we went up one, we went up our y value. Our constant turned out to be 166. So each time I went up one value in x, my y value went up 0.166. So as I come over here, I'm going to be able to determine that direct variation by looking at my table. And I know that my direct variation is going to be the relationship of y to x. And if you're curious where that came from, I mean, I have this. Y equals kx, and if I wanted to isolate k, I would divide both sides by x, and there we go, y over x equals k. Now, as I go to do some substitution here, I know that if I take y over x, I get 6 over 4 is going to be equal to 3/2. I take the next one, and I have 12 over 8. 12 over 8 is also going to be 3/2. And then finally, I have 15 over 10, and that too is going to be 3/2. So it looks like for the data in the table, does y vary directly with x? And it looks like, yes, we have a constant of variation. Our constant of variation is going to be 3/2, and the equation then would look like, yes, it does. Therefore, y equals 3/2 x, and there's my equation. And if we go ahead and do this for our other choices, we have 3.2 divided by -2, which is going to be equal to -1.6. And we have 2.4 divided by 1, which is going to be equal to 2.4. Well, I know right here, if I compare these two, those are not the same. So I don't have a constant of variation, but I'm going to go ahead and do this next one, though, just to continue on with and prove a point. 1.6 divided by 4 is going to be 0.4, and none of those are the same, so of course, no, I do not have direct variation. And if I go on and do the following example here, and again, direct variation is y divided by x, so I'm going to have -3 divided by 4, which is going to be equal to -0.75. I have 2.25 divided by -3, which is going to be equal to -0.75. And I also have, well, -0.75 divided by 1 is going to be -0.75. So it looks like, yes, I do have a constant of variation. So yes, I do, and therefore the equation is going to be y is equal to -0.75x. So there you have it. We were able to create that direct variation equation from a table. And if you look, what operation can you perform to find the value of k so that you can write the equation of direct variation? Well, given that table, all you had to do was divide your y by your x value. And that will identify the constant of variation if there is one. And of course, all of them will have the same value. And if you think about it, the constant of variation, k, the constant of variation is nothing more than what would be my slope. So there you have it. And remembering that the characteristics of direct variation, the graph goes directly through your origin, 0, 0, and it has that constant rate of change, or the constant variation, and it is that direct variation where my slope value is going to be that k. So just remember y equals k over x, and it's going to pass through my origin, 0, 0.